I'm going to be discussing some data from the hemp proficiency testing program that we manage. We got involved in testing hemp for total THC for Kentucky Department of Agriculture a few years ago in 2017. And when we first started, there was not a proficiency testing program, and I realized the need for one. It's very important to have a program like this where the labs can compare their results and determine how well they're doing with respect to other laboratories. What I'll present today is total THC results from this program and how it relates to making regulatory decisions. This is the home webpage for our hemp PT program. The program was started in the fall of 2018. Every year in the program, 4 samples are sent out, and they're sent out in fall in 2 shipments. Two samples are sent out in September and 2 in November. The laboratories are asked to analyze the samples for cannabinoids, THC, the acid neutral forms, CBD, the acid neutral forms of that, and total THC, total CBD. They also can report results on all the other minor cannabinoids and heavy metals. In a PT program, it's very important to prepare a sample that is homogeneous. We take great pains to mix the sample very well, lay it out like you see here in a thin layer, and take scoops of the samples to fill up these packets that are in the background of the photo to send out to the various different labs. This is a diagram of a bell curve, and it is very instrumental in analyzing data from a PT program. The height of the curve is the number of observations from a set of data. The very center of the curve is the average for a set of data. We would collect data from all the different labs for total THC, calculate an average and a standard deviation. Going from the right of the highest point on the curve is the number of observations obtained for the average plus incremental standard deviations, and to the left is also the average minus incremental standard deviation. Approximately 63% of the data is expected to be within -1 to +1 standard deviation. 95% of observations are within -2 to +2 standard deviations of the average. When we receive results from the different laboratories, and if their result falls within this region, they're given a lab report indicating that their test result is compliant. It fits within the norm of all the other results that the laboratories have submitted. If the lab submits a result that is outside this region, they're given a warning on their lab report that their result is outside the norms of the results submitted by other labs. So what this slide shows is the distribution of total THC in 4 samples in the program. And I'm focusing on samples that have a total THC concentration of 0.3% or approximately 0.3%. And you see there's a wide variation of results obtained from the different labs for these different samples. The label of the samples is shown on the left-hand side. The 3rd and 4th character is the year of the program, and the month is the month that the sample was shipped out. The first sample in 2018, you see a wide variation. This same sample sent out to all these different labs range from 0.26 to 0.475% total THC. And I also forgot to mention for this slide that the data points you're seeing here are just the compliant test results from the laboratories. So these are the results that labs would say that their result was within the norm of all the other laboratory results. So you see in 2018, we were observing quite a big variation in sample results for total THC. It improved somewhat in 2019, and although the range is still as high as 2019 in this 2020 sample, it's interesting to note that there is a larger cluster of data of samples at about 0.32% total THC. The hope is with time, with laboratories understanding where they lie in the spectrum, that there will be improvements and this variation will decrease with time. The number of labs participating in these different rounds are shown on the right-hand side. 38 labs presented a result for total THC in 2018. In 2019, it was 52 and 60 labs. And in the 2020 sample was 64 labs. This 0.3% was presented, is a very important, as Doris presented, is the important concentration that defines whether a sample is hemp or not. If it's less than 0.3%, it's legally hemp. If it's greater than 0.3%, it's illegal. Well, I think it becomes quite obvious that this variation has a lot of implication on a decision that has to be made on whether a sample is legal or not. If you are going strictly with that concentration of 0.3%, the same sample sent out to all these different labs, you had some labs testing it above 0.3%, where it would be considered illegal, and some labs testing it less than 0.3%, where it would be legal. So there has to be an accounting of this variability with respect to decisions made on whether a sample is legal. Well, the USDA has taken the approach on accounting for this variability by having each lab determine their own measurement uncertainty. And this is outlined in the USDA's interim final rules, which we do not follow yet in Kentucky, but this is what's outlined in their current interim rules. And what this entails is each lab analyzes the same sample in their lab repeatedly over time, and they determine the variability of their results with that one sample. They also can measure a sample that has a known concentration of THC to determine how close their concentration is with that known concentration. So there is a process to go through to calculate that measurement uncertainty. And I'm going to go through a hypothetical example of that in this slide. Let's say a lab had a result for total THC being 0.358%. And they also went through the process of determining their measurement uncertainty, and it was 0.08%. So they would need to report not only the concentration that they observed, but a plus or minus of a measurement uncertainty of 0.08%. This graph displays what that entails in interpreting the measurement uncertainty with the concentration. The red dot is the concentration of THC being 0.358%, and the measurement uncertainty is shown in the arrowed line here, where there is uncertainty in that actual result, and what the lab is reporting that real concentration, the actual concentration of total THC, is somewhere in between the arrowheads of that line, somewhere in between 2.75 and 0.435. So if they reported this result, since the range of that line overlaps 0.3%, there's some probability that the real actual concentration of THC is less than 0.3%. So this result would result in a decision that the sample is legal, since there's some probability that the concentration is less than 0.3%. Well, if this same sample was tested in another lab and that lab got the same exact result of 0.358%, but their measurement uncertainty was 0.04%, then the expected real concentration of THC would be somewhere in between 0.315 and 0.395%. So the outcome of this analytical result from this lab, the same concentration but a different measurement uncertainty, would be that the sample is illegal because the certainty of where that concentration THC is above 0.3%. Well, I think you could start to see where this adds some disadvantage with respect to interpreting results from different labs with different measurement uncertainty. Disadvantages are shown here. If a regulatory agency relies on multiple labs with different measurement uncertainties, one lab might have a larger uncertainty than another, and different results can be obtained from the different labs. Private labs having different measurement uncertainties than regulatory labs. This could just add confusion in the marketplace. And also, determination of measurement uncertainty is not trivial. There are many documents that outline how to determine this, and they're all slightly different. And I don't mean to insult anybody's intelligence, but you need a great deal of statistical knowledge to understand and interpret these documents. I am not at all certain that all the labs are determining measurement uncertainty correctly or the same way. Also, this is a complicated topic, and describing this is difficult. Communicating the effect of different measurement uncertainties to growers and processors, I think, has some challenges. This graph shows the distribution of measurement uncertainty of 32 labs in the hemp PT program, and you see that there's a wide range with median of 0.04%. So measurement uncertainties are all over the place. Just for reference, what Doris just presented, the current measurement uncertainty that we use from the pilot program that was started years ago is 0.099. So you could see where it falls in this range of data. 0.099 would be right there. I just realized I'm not using my arrow correctly. I'm pointing on my previous slides. I apologize. So what's an alternative? The alternative that we proposed and we provided in comments to the USDA's interim and final rules is to use a universal measurement uncertainty. A measurement uncertainty that is based on the variability of data from a PT program. This is one sample and it's showing the variability. This average concentration was 0.322%, and the measurement uncertainty would be 0.08% if it encompasses all this data that was compliant in the PT program. So 0.08% would be a measurement uncertainty that would be the same used for all labs. So the advantage is one consistent measurement uncertainty for all labs to use, avoid confusion on different measurement uncertainties from different labs, and easier to communicate the effect of measurement uncertainty if only one measurement uncertainty is used. I'd be remiss if I didn't mention the people involved in this PT program. It takes a lot of individuals to make a successful program, and every one of these individuals contributed mightily to the efforts of getting a quality program in place.